Hi, welcome back to another video of practical funkiness in C#, this time introducing the function bind. Let's start by addressing some technical terms so we can get these out of the way before we dive into the details. The bind function in functional programming is used to chain together containers called monads. In the previous video, our container had a map function which turned it into a functor in the functional programming world. Excluding the monadic laws for now, a container with a bind function qualifies as a monad. In practice, it's common for a monad to provide both map and bind methods. On screen is another generic container, chain. Since this class implements bind and return or an equivalent method and satisfies the monadic laws mentioned within the comments, it can be classified as a monad. Using an implicit operator instead of return would likely still qualify this as a monad. That's it for today regarding the functional terms. Hopefully you now have a clearer mental picture. A monad is essentially a container that has both a bind method and a return method, such as a factory method or an implicit operator. Looking at our chain class, we can see that the return method simply takes a value and wraps it in a new chain monad. In a more realistic scenario, this method would likely be named something like create or wrap, but I've kept it as return for now to stay consistent with functional programming terminology. The bind method is similar to the map method in that it accepts a function that operates on a value of type t. However, while map returns a transformed value wrapped inside a new chain, bind is specifically designed to return a new chain that wraps the modified value. This makes bind suitable for chaining operations on monads, where each operation may involve a transformation or computation that produces a new monadic container. Both bind and map can be used to transform the value inside the container into a different type. The key difference is that bind allows for chaining operations that can involve more complex transformations, as unlike map, bind can return the transformation already wrapped inside a monad. In some contexts, bind is also called flat map because it flattens the result. That is, it prevents the creation of nested monadic containers. Instead of returning a chain of t out, bind ensures the result is always a single layer monadic container, which simplifies working with chained operations. I think that's enough theory for today. Let's see some demos. The first demo is to show that the generic list, which you are likely familiar with, implements an equivalent method to bind called SelectMany. We first create a list of t with a single value 10. Next we create a chain of int assigning it the value 10. We use the SelectMany method on the list of int. This operation flattens the result, creating a new list with the value from the original list multiplied by 2. Equally, we use the bind method on the chain of int. The lambda function multiplies the original value by 2 and returns a new chain of int. This operation flattens the result, ensuring we get a chain of int instead of a chain of int. Let's run it to ensure that the original values are both left intact and the new values are as expected. Now let's look at a more realistic use of bind. In this example, we're demonstrating how bind enables chaining operations in the context of a monad, specifically our custom chain of t type. All of the class methods return either a chain of decimal or a chain of string, except for the apply tax method, which is, in functional terms, a pure function that simply returns a value, i.e. a decimal, without it being wrapped in a chain monad. Let's walk through the first scenario, bind result. We start by calling process transaction with an amount of 1000. This wraps the number 1000 into our chain of decimal container. Next we call bind with deduct transaction fee. This deducts 5% as a transaction fee and returns a new container with the updated amount. Then we bind again, this time with apply discount. A 10% discount is applied and once again we get a new chain of decimal. We continue with complete transaction, which simply logs and passes along the final amount, still wrapped. And finally we bind this with format invoice, which transforms the decimal into a formatted string and returns a chain of string. So now the bind result variable holds a monadic container with our final formatted invoice. Moving on to the second example, bind result with map. This pattern starts the same, process order with a value of 1000. We then bind to apply a discount, but next we use map instead of bind. Why? Because apply tax is a pure function, it returns a simple decimal, not a monad. So to keep it in the elevated world, we use map to lift its result back into the monadic context. Then we continue with bind complete order. Just like before, we wrap the final amount again. Finally, we bind with format invoice to convert the amount into a friendly string format inside a chain of string. The result is the same, clean, composable steps using monadic chaining, and by mixing bind and map, we control how values flow through both effectual and pure operations. This is the power of monads. Controlled transformation, clear composition, and no surprises. Let's run the code and view the results. Okay, I think that's enough for today, but hopefully all this scary sounding monad stuff is not that scary after all. Next time, after we have seen the match function, we will then have enough pieces of the functional jigsaw in place to see more real-world examples. I have updated the GitHub repository with the new code, so it's all available to download. As always, feel free to leave good or bad comments and I will do my best to answer any questions raised. Until next time, bye for now.